magic. We're learning this together. It's magical. Today we talk about cattle rate oscilloscope. What is a cattle rate oscilloscope? In short, we usually call this the CRO. It's a device that is screen. So if you imagine it, if your device like this, it has a screen here, it has a lot of channels where you can input wires into, it has a lot of dials, etc., etc., etc. But here, we'll be interested in seeing what is inside the screen here. So cattle rate oscilloscope is two devices. On the x-axis, it actually shows time. So you can say in the x-axis, it acts like a stopwatch. On the y-axis, it shows V in volts. We can call it PD, so potential difference. So potential difference in volts, time in seconds. So in the y-axis, it acts like a voltmeter. So instead of having a voltmeter separately, a stopwatch separately, you can actually have a cattle rate oscilloscope which can actually measure two things. But the coolest thing about the voltmeter and stopwatch in the CRO, it can actually measure it in real time. So if your PD actually changes, your potential difference actually changes, it can actually monitor real time. So if it's positive, if a few cycles later it becomes negative, you show the negative value and literally become a much more easy device, especially if you have something that has frequencies. Okay? So if you're dealing with frequencies, then it will help you a lot. Something that actually follows alternating current format. Since this is time here, most of the time we'll be looking for the period. After the period, we can get the frequency. So in this component here, we can A, measure period, B, determine frequency. Keyword, can we measure frequency? No. We can only calculate. Therefore, we determine frequency. Can we determine period? No. We can measure period. Okay, so remember the usage of these two words, it will help you a lot in the future. This part, the voltage component, is quite straightforward. Another thing you need to know is in these dials here, because when you have, for example, a screen that looks like, let's say this is the screen component here, if it looks something like this, you can't really see the waves. So what do? There's a knob on the next to the screen where you can adjust something called the time-based setting. Let's say this one is adjusted. It takes a reading. Let's say you want to make it viewable. So what you do, you turn the time-based setting, and then you notice that this, which looks not like a wave, once adjusted, it will look something like this. Okay? That's why we have something called the time-based setting. You change the time base, also known as the x-axis setting. Like number 3, you change the scale so that you're able to view how many waves it is. Usually when a time-based setting, it's always good to have at least viewable at least 2 or more waves. As we go through the questions, you see typical number of waves that you actually will see or need in order to determine your frequency and measure period nicely and your voltage. We need enough information. We will not be dealing with using a CRO in the course, but we have to understand how do we analyze what we see on the screen. Okay? So use this video as a recap of what a CRO is for, and then when we do the questions, if you want a reminder of what you're looking at, when there's a screenshot with the graphs, go back to this video, and hopefully you understand more. Please provide